Greetings, data enthusiasts. We're back with another exciting chapter in our explainable AI saga. And today we're tackling logistic regression on a stroke dataset I've got handy in my datasets folder. I'm working in Google Colab, breaking this down into digestible code blocks so you can join the ride. We're using a file called healthcaredataset-data.csv, which you'll be able to snag for yourself. Check the link we'll share. We'll pre-process this data, balance its quirks, train a logistic regression model with Interpret, and then unpack its predictions with those incredible local and global explanations. Get comfy. This stroke prediction deep dive is going to be a blast. Let's lay the groundwork first. In Colab, I start with pip3 install interpret to grab the interpret library, our golden ticket to XAI insights. Then I load up a toolbox, pandas and numpy for data crunching, matplotlib for plotting, though we won't need it much today, and a lineup from sklearn and mblern, train test split, random oversampler for balancing, plus F1 score and accuracy score for evaluation. From Interpret, I pull logistic regression from the Glassbox module and set up inline visualizations with set visualize provider and inline provider. Now, the dataset, I load it with pandas read CSV from datasets /healthcaredataset-stroke-data.csv. The head reveals a treasure trove. ID 9046, gender male, age 67, hypertension 0, heart disease 1, and stroke 1. It's a snapshot of patient health, and we've got work to do. Before we dive deeper, let's play data detective. I run dataset.isna.sum, and bam, 201 missing values in BMI, but 0 elsewhere. That ID column? Just a tag, not a predictor. So I ditch it with dataset.drop, axis 1, and place true. For BMI's missing spots, I calculate the mean, 28.893237 to be exact, and fill them with dataset.bmi.fillna. A follow-up isna.sum shows all zeros. Perfect. Then dataset.info spills the details. 5,110 rows, 11 columns post-ID drop, with floats like age and average glucose level, integers like hypertension, and objects like gender. 5 categorical columns catch my eye. The describe method adds flavor. Age ranges from 0.08 to 82. Mean 43.23. Average glucose level hits 271.74 max. BMI's mean is 28.89. And stroke's mean is 0.048728. Only 4.87% positives. That tiny stroke rate screams imbalance. We'll fix that soon. Next up, those categorical columns: gender, ever married, work type, residence type, smoking status. I snag them with select types, include object, then whip out pandas get dummies for one hot encoding, prefixing like gender female, and casting to integers for the model. I concat these new columns, 17 of them, to the dataset and drop the original 5. The updated head? Gender male 1, age 67, average glucose level 228.69, BMI 36.6, stroke 1, 22 columns total. Now, I split X as all but the last column and Y as stroke using iLock, then use train test split with 20% testing, random state 2021. But that 4.87% stroke rate? Trouble. I deploy random oversampler with sampling strategy minority, convert xtrain and ytrain to numpy, oversample, and revert to pandas. This balances our training set. Minority strokes now match the majority. Let's train. Time to build the model. I initialize logistic regression from Interpret, setting random state 2021, feature names from xtrain columns, penalty L1, and solver liblinear. L1 helps with feature selection by zeroing out weak links. I fit it on xtrain and ytrain. Training's complete. Predictions on X-test give us an accuracy of 0.9501, 95.01%, and an F1 score of 0.4872. Whoa, hold up. 95% accuracy sounds amazing, but that F1 score? It's macro-averaged, meaning it balances precision and recall across classes, and 0.4872 is mediocre. Why? Stroke's rare, only 4.87% in the original data, so the model's great at predicting no stroke 95% of the time, but it flounders on the rare yes stroke. Oversampling helped training, but the test sets still skewed. XAI will reveal more. Let's dig in. Here's where XAI steals the show. Local explanations. I run LR.explainLocal on the first 100 test samples. For the first record, it predicts 0, no stroke, matching the true label 0. Feature contributions. Age at 5.512956 is a colossal push toward stroke. Huge risk. Average glucose level adds 0.2769, a modest nudge. But Ever Married Yes pulls back with negative 0.4632 and BMI subtracts 0.3521, both resisting stroke. Most others, gender male, hypertension, heart disease, are 0, no impact here. The graph you're seeing? A bar chart with a skyscraper orange bar for age stretching right, dominant positive force, joined by a smaller orange bar for average glucose level. Blue bars for Ever Married Yes and BMI jut left, countering the risk. Age screamed stroke, but marriage and BMI tipped it to no, a tight battle. Let's zoom out to global insights with LR.explainGlobal. Feature importance across all predictions. Age at 0.0788, hypertension at 0.3396, heart disease at 0.2073, and work-type children at 0.1622, all positive, increasing stroke odds. Average glucose levels a tiny 0.0038, barely a whisper. On the flip side, Ever Married Yes is negative 0.4632, work-type self-employed negative 0.4324, smoking status never smoked negative 0.3112, and BMI negative 0.0116, reducing risk. Gender females negative 0.0336, residence type urban negative 0.0356, small pulse. The graph on screen? Horizontal bars. Orange for age, hypertension, heart disease, and work type children extend right, boosting stroke likelihood. Blue bars like Ever Married Yes, work type self-employed, and smoking status never smoked stretch left, lowering it. Hypertension's a star here. 0.3396 is hefty. What's this output telling us? Let's unpack it. The head showed age 67, glucose 228.69, stroke 1, high-risk traits. Stats confirmed stroke's rarity, 4.87%, explaining our 95% accuracy but weak 0.49 F1. Locally, ages 5.5, one contribution dwarfed everything. Imagine a 70-year-old patient. That alone flags risk. Glucose helped, but marriage and BMI flipped it. A real-world tug-of-war. Globally, hypertension's 0.3396 and heart disease 0.2073 align with medical intuition. Health conditions matter. While Ever Married Yes at negative 0.4632 suggests marriage lowers stress or risk. Smoking status never smoked cutting odds by 0.3112. Maybe healthier habits. This isn't just prediction, it's insight. For a doctor, its age and hypertension raise red flags, but no smoking helps. XAI makes it actionable. Let's bring it home. We grabbed this stroke dataset, yours to download, cleaned 201 BMI gaps, balanced it with oversampling, and hit 95% accuracy with a logistic regression model. But that 0.49 F1 score? A wake-up call. Rare events like stroke need more than accuracy. Local explanations showed age ruling one prediction. Global ones crowned hypertension and heart disease as key drivers. Interprets visuals, those orange and blue bars, turn a black box into a crystal ball. Tweak this model, try different samplers, or adjust penalties. It's all in your hands with the dataset we're sharing. I'm hooked on this XAI quest. Hope you are too. See you next time for more data magic.